Good morning, ladies and gentlemen. For this short video, we're going to look at the ambiguous case of the sine rule. This occurs, or has the potential to occur, when you have two sides and a non-included acute angle. What I mean by that is when you have two sides and you're given an angle that is acute, meaning it's less than 90, and it's not between the two sides. Right? So what we're looking at here is a setup for a possible case of ambiguous case of the sine rule. Now, ambiguous means there's more than one answer. So here, the potential for a second answer comes from the fact that the 8 is fixed, the 15 is fixed, and the 30 is fixed. But what's not fixed is the length of this line or this angle. So those two can change, and the information is still the same regarding the question. So feasibly, instead of drawing a 5 there, I could draw a length 5 here. Should be about there. Alright, now I'm hoping you can see that this length will be the same as that length there. What this means is we still have a triangle with a 30-degree angle, and our new triangle is this one. Our new triangle still has a 30-degree angle. It still has a side of 8, and it still has a side of 5. So the information is exactly the same as before. Alright, so let's just get rid of that big bulky red line to show you what we're dealing with. And now, what we're asked to do is find the length of this angle C. Alright, and we can see when we're hunting for angle C that this could be acute, or what we'll call C prime, or C alternative, could be obtuse. So here we're going to find two possible values for the answer for C. Alright? And to do it, we're going to use the ordinary sine rule. So let's take the original triangle into account. If we take the original triangle into account, what we have is we have side B over angle B equals side C over the sine of side angle C. Substituting the numbers, we get 5 over sine 30 equals 8 over sine C. Right. And now we can do a couple of different things from here. We can either do it algebraically, or we can put it into nsolve. If we put it into nsolve, we have 5.1, I'll do it and bring it up in a sec. Alright, we have 5 over sine 30 equals 8 over sine x. 5 over sine 30 equals 8 over sine c. So in this case, we're finding x. Hit enter. And note that we've used nsolve. Nsolve gets us one number. The first solution, 53. Alright, so what that's telling us is that the angle for C equals 53.13 degrees. But I'll just call it 53 for now. Say we're asking to the nearest whole degree. That there's 53. Alright, now, that's got us one solution. How could we get the other? The other solution takes a little thinking. What we have to recognize is that this is an isosceles triangle. So getting rid of the blue. This is isosceles. Those highlighted lengths are the same, which means the base angles are the same. If the base angles are the same, it means, that this other angle here is also 53. Now, if that's 53, it means the alternative for C, this one here that we're use a calculator to check. So our two solutions here are 53 and 127. Now, ambiguous case doesn't always exist. So how do we check whether it exists or not? Using this sort of logic, or using other methods in the calculator, you can come up with two solutions all the time. The trick is that up to more than 180. As in, the answers meaning the two angles you have can't add up to more than 180. So if we have 53 and 30, that's less than 180, so that's fine. If we have 30, because we're given that, and 127, that's fine as well because they add up to less than 180. If the sum of one of these angles here and 30, the other angle we're given, was more than 180, then that would be an impossible triangle. Because if it was equal to 180 or more, there would be no room for an angle up the top here. So, the way we do it is we check when we have this scenario, two sides and not included acute, whether we can draw a separate line in, and therefore there might be two different angles. Similarly, by the same logic, this length here, CB, could be two different lengths. There are two possibilities there. And the sine rule will throw out a pair of angles that finds us each length. And then we just got to check that this angle and these angles don't add to more than 100. These questions are relatively rare, but they do come up and it is worth looking through them. We will do some more practice in class, clearly.